Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss hardness of water and soap. Hardness of water and soap. Hardness of water is due to the presence of soluble salts of calcium, magnesium, and other heavier metals in water. Hard water does not give leather easily with soap, but produces a white scum or precipitate with soap. This is due to the formation of insoluble soaps of calcium and magnesium. When the calcium and magnesium ions react with soap. What is the soap? Soaps are sodium or potassium salts of higher fatty acids such as oleic acid, palmitic acid, and stearic acid. Soaps are sodium and potassium salts of higher fatty acids, as for example, oleic acid, palmitic acid, and stearic acid. Fatty acid example I am telling you that C17H35. This is the example of stearic acid I am telling you. C17H35 COOH. This is actually COOH carboxylic group, acid group, and in this carbon is 17 and hydrogen is 35. That's why it is called higher fatty acids. Higher carbon and hydrogen both are more, C17H35. Then in this COOH group is attached. Then COOH group is called carboxylic acid group, or simply acid group, COOH carboxylic group. Then this is actually example of stearic acid. Then in this C17H35 COOH, in the place of COOH, in the place of H, when sodium or potassium comes, anyone, either sodium or potassium, then it is called salt. If sodium is there, it is called sodium salt of fatty acid. Here fatty acid is stearic acid. Stearic acid is fatty acid. Then it will be called sodium salt of fatty acid. Sodium salt of fatty acid, here stearic acid, and it is called sodium stearate. Sodium stearate, because it is the salt of sodium. Generally, salt is formed when acid reacts with base. Base, as for example, NaOH, sodium hydroxide, NaOH. Then in general, when acid and base react, then salt is formed. Simple example, HCl plus NaOH. It forms NaCl plus H2O. NaCl is a salt. Okay, like that way here, stearic acid plus NaOH base. Also you can tell alkali. Base which dissolves in water is called alkali. All bases are not alkalis, but all alkalis are bases. Okay, remember it. Then here stearic acid plus NOH, when both will react, then in stearic acid COOH group, H is there, that H will be replaced with sodium, and this H will go with OH and it will form water. Hence, it will form sodium salt of stearic acid and it is called sodium acetate. And this sodium stearate is the example of soap. Sodium stearate means salt of fatty acid. This is called soap. And other example I am telling you, that is this is another example, that is for sodium stearate. Now I told, now you can tell potassium stearate also. If in the place of H potassium comes, then it is called this is salts, potassium salts of higher acid. Potassium salt of higher acid. Then here potassium stearate. You can tell potassium stearate. Like that way, if palmitic acid is there, then you can tell sodium palmitate, and after that if oleic acid is there, then you can tell sodium oleate or potassium oleate, and with palmitic acid sodium and potassium palmitate. Okay, then these are the example of soap. Chemical composition I am telling for the soap. Soap is salts of higher fatty acid, and higher fatty acid example I told you: palmitic acid, oleic acid, stearic acid. Okay, then now come to the this hardness. Then hardness is due to the presence of soluble salts of calcium, magnesium and other heavier metals in water. These salts are present in water. Hard water does not give leather easily with soap, but produces a white scum or precipitate with soap. This is due to the formation of insoluble soaps of calcium and magnesium. When the calcium and magnesium ions which are present in water react with soap. Now action I am telling, action of hard water on soap. Generally, if in hard water, if water is hard, then this hard water will give white scum or precipitate with soap if water is hard. Okay, if water is soft, then it will not give precipitate, means white scum it will not give. Okay, if you are using hard water, to clean the cloth, or if you are using soap, then if white scum is coming, precipitate is coming, then you can tell water is hard. Water is hard, you can tell only when you will use that water with soap. Then if white scum or precipitate comes, then you can tell water is hard. If white scum or precipitate, particularly for I am talking about this for the cloth cleaning, cloth that is the washing soap I am talking about, washing soap. Then white scum and precipitate is due to hard water, means in that water calcium salt or magnesium salt is present. Then action of this salt, means calcium or magnesium salt with soap, I am telling you with one reaction. Okay, that reaction is very simple. That example I am telling with sodium stearate only. Soap is sodium stearate. Washing soap means sodium only. Okay, sodium salt of any higher fatty acid. Sodium salt of any higher fatty acid is called washing soap. Washing soap. Okay. And if potassium is there, then it is called bathing soap. BATH, bathing soap. For the bathing purpose, soap is different, and for the cleaning purpose, soap is different. Then for the cleaning purpose, cloth cleaning, that is a sodium salt. Sodium salts of higher fatty acid is used. And for bathing soap, potassium salts of higher fatty acid is used. This is the difference. Then sodium is hard and potassium is soft. Then here suppose water is hard. Then what will happen if we will use the soap? Washing soap, if you are using with water which is hard, then what reaction will take place? That reaction I am telling you. Then in water, calcium ion will be there. Certainly, if water is hard, then certainly calcium ion will be there, or magnesium ion will be there. Okay, and also in that water, sulfate and chloride will be present. Okay, essentially that sulfate ion will be there and chloride ion will be there, and as a cation, calcium and magnesium will be present. Then calcium of the water reacts with soap, and sodium will be replaced by calcium. Then now you know that calcium has 2 positive charge, sodium has 1 positive charge. Hence, when calcium will come, then this 2 stearate ion it will attract, because sodium it has only 1 positive charge. That's why it was attracting, or it was joined with only one. So you can say stearate, only 1 stearate ion. That was 1 negative, 1 positive. It neutralized. But now if calcium will come, then calcium is 2 positive charge. Then it is equivalent to 2 stearate negative ion. Both will have 1 stearate ion, means 1 negative. But calcium is 2 positive. Hence 2 stearate ion it will attract, and it will form C17H35 COO whole 2 Ca. Now calcium has 2 positive, hence it attracted 2 stearate ion, and it forms calcium stearate. Now in the place of sodium stearate, now it is forming calcium stearate, and it will come out as the precipitate. White scum is due to this calcium stearate. Calcium calcium stearate, okay, white precipitate, and it will settle down. It will settle down that in water, okay, and sodium ion will come out plus 2Na. Means these two molecules of stearate ion, sodium stearate you are using, and that two molecules equal to with one calcium ion, and it gives sodium stearate, and this due to this sodium it will give calcium stearate, and due to this calcium stearate white scum comes, and it is insoluble in water, that's why it will settle down. Then if water is hard and you are cleaning the cloth, soap you are using, then more soap will be required, because all calcium ion should precipitate, should come out from the water. Only then you can say when all calcium will react with soap, only then you can say cloth will clean. Means more soap will be required to clean the cloth. Until calcium is there, cloth will be not cleaned. That's why more soap will be required to clean the cloth. Okay. Then now I told about the calcium. Same way for magnesium. Magnesium, if it is present in water, then that is also called hard water. Maybe magnesium may be present in the form of magnesium chloride, magnesium sulfate. Just like calcium also, same way calcium, it may be present in the form of calcium sulfate, calcium chloride may be present. Then if magnesium may be also there. When calcium is there, then chances are there magnesium will be also there. Then magnesium will also have two positive charge, Mg 2 plus. Then again this magnesium also can react with sodium stearate, and again same way reaction, that two mole it will attract because it has two positive charge, and sodium stearate has one negative. This stearate ion have one negative charge. Sodium is a one positive. Okay. Then this stearate has one negative. That's why this magnesium also will attract two stearate ion, because they have only one negative charge. Then now same way it will form C17 H35 COO whole 2 Mg. Means Mg attracted now two molecules of stearate ion, and it is insoluble in water. That's why it will come out as a precipitate or white scum, and sodium will be separated plus 2Na, sodium ion. Then this reaction actually takes place when you are cleaning the cloth. Okay. If you are cleaning the cloth, then this reaction takes place, and if water is hard, then more soap will be required. Okay. Only then it will clean the cloth. Until calcium and magnesium is present in water, it will not clean, cloth will be not cleaned. Okay. Hence more water is required, more soap is required. Okay, because now we have to clean all the things. Then here certainly more soap will be required. Then this I have told you, action of or reaction, you can tell, reaction of calcium and magnesium with this reaction of calcium and magnesium present in the water with soap during the cleaning of cloth. Now I want to tell furthermore, soap can produce leather only after all the hardness causing ions. Soaps can produce leather only after all the hardness causing ions. Hardness causing ions are precipitated as insoluble soap. Hence, it requires a large quantity of soap to produce leather. Thus, water which does not produce leather readily the water which does not produce leather readily with soap is called hard water. On the other hand, water which produces leather easily with soap is called soft water. This is a very important point. Water which produces leather easily with soap is called the soft water. Okay. If soft water is soft, then easily you will get leather, and hard water is there, then this it will give you more, you can say, this scum, white precipitate, because it is insoluble, and soft water is soluble, but hard water is insoluble. Whatever scum and white precipitate form, that is insoluble. Okay, then soft water produces leather easily with soap, that is called soft water. Now, hardness of water can be classified as temporary hardness and permanent hardness. Temporary hardness is also called carbonate hardness. Temporary hardness is caused by the presence of dissolved bicarbonate of calcium and magnesium. In hard water, it is hard water is due to the chloride and sulfate, but temporary hardness is due to the bicarbonate of calcium and magnesium. This hardness can be removed by mere boiling of water. Simply, if you boil the water, then a temporary hardness will go. When bicarbonates are actually when you boil the water, then temporary hardness will go. How it will go? Then when bicarbonates are at that time, bicarbonates are converted into insoluble carbonate. In water, suppose a bicarbonate is there, calcium bicarbonate is there, or magnesium bicarbonate is there. Then if you will heat it, boil it, then this bicarbonate will convert into carbonate, or calcium carbonate or magnesium carbonate. It is insoluble. It will settle down in the, you can say, pot in which you have heated utensils. Wherever you have heated, there it will settle down after heating in the form of calcium carbonate, magnesium carbonate. These are insoluble, which you can filter it. You can filter it and you can drink it. And during this heating, some carbon dioxide gas also comes out, because calcium bicarbonate will break into calcium carbonate plus carbon dioxide plus H2O. Then H2O, no problem, you are using H2O. But calcium carbonate is insoluble, and that will settle down in the utensil, and carbon dioxide gas will go into the atmosphere. Then in this way, you can temporary hardness can be removed simply by boiling. And magnesium if suppose magnesium bicarbonate is present, bicarbonate is important here, then magnesium bicarbonate is important, then that also will break into magnesium carbonate plus carbon dioxide. Then carbon dioxide will go to the atmosphere, and magnesium carbonate is again insoluble. It will settle down, and that can be filtered. Now come to the permanent hardness. Permanent hardness is very difficult, very important, and is very difficult to remove. Permanent hardness is also called non-carbonate hardness. Non-carbonate hardness. Then already I told you permanent hardness is caused by the dissolved salts of calcium and magnesium other than bicarbonate. Then other than bicarbonate, what may be there? Anion. Permanent hardness is caused by the dissolved salts of calcium and magnesium other than bicarbonate. Bicarbonate is also salt. Calcium bicarbonate, magnesium bicarbonate is also salt. But here other than bicarbonate means calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, particularly chloride and sulfate of calcium and magnesium. If they are present in water, then that water is called permanent hardness. This permanent hardness is due to this salt. Calcium salt means calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate. Okay, these are the main reason for permanent hardness of water. Then this salts I am talking about, they are chloride, sulfate means calcium chloride, calcium sulfate, calcium nitrate, etc. Okay, magnesium chloride, magnesium sulfate, magnesium nitrate, these are responsible for permanent hardness. Nitrate also. Unlike temporary hardness, permanent hardness cannot be removed by boiling. Removal of the hardness requires some special chemical treatment methods. Okay. The sum of temporary and permanent hardness is called or referred to as total hardness of water. Total hardness of water means temporary hardness plus permanent hardness. The hardness of water is expressed in terms of equivalent calcium carbonate, or you can tell in the term of calcium carbonate. Okay, and this unit, the units, how will you express hardness? The units normally used to express hardness are ppm, parts per million, or milligram per liter of calcium carbonate equivalents. Unit, I am telling you, the units normally used to express hardness are parts per million, ppm, or milligram per liter of calcium carbonate equivalent. Sometimes in these calcium magnesium may be present very less. In 1 liter may not be present. Then it is expressed in, you can say, parts per million. In a bigger amount of water, some calcium magnesium may be present. Then ppm is used only there where you can say calcium and magnesium is found very less. In sometimes in 1 liter may not be present. Then in higher quantity, some quantity may be present. Okay, that's why in that situation parts per million is used. And if it is present in little more quantity, then in liter, suppose it is present, then it is expressed in the term of milligram per liter, mg per liter, milligram per liter of calcium carbonate equivalent. Now, why only we are expressing in term of calcium carbonate equivalent? Why not in others? Why not in magnesium, in terms of magnesium? or in terms of other ions? Then its reason is that calcium is found in more quantity in comparison to the other magnesium or other cation. Now here this parts per million means ppm is the parts of calcium carbonate equivalents per million means 10 to the power 6 parts of the water, means in 10 to the power 6 parts of the water. How we can say parts how part means this calcium carbonate, calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate, how much parts are present, okay, in 10 to the power 6 parts of water. How much you can say means per million, how much or parts, how much parts of calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate is present, okay. Then meaning of parts per million I have told you. I can just I can clear more by one example. Actually hardness of water is very common everywhere in the world. Everywhere you are getting only hard water. Soft water is very less. All ocean and sea and many other sources of water, sometimes groundwater also, but generally it is soft water. Lake is also soft water, but ocean and sea have this thing hard water, and so one should know the what is actually hard water and what is its meaning, okay. Then I want to clear it more by giving one example. Suppose in a sample of water which contains 16.2 milligram of calcium bicarbonate, in that water 16.2 milligram of calcium bicarbonate is there. 29.2 milligram of magnesium bicarbonate is there. 29.2 and 33.3 milligram of calcium chloride is there, and 18 milligram of magnesium sulfate is present, and 55 milligram of sodium chloride is present per liter of water, okay. These five data are there. First data is of calcium bicarbonate 16.2 milligram in 1 liter. 16.2 milligram of calcium bicarbonate is there, and 29.2 milligram magnesium bicarbonate is there in 1 liter water, and 33.3 milligram of calcium chloride is there, and fourth data is 18 milligram of magnesium sulfate is there in 1 liter, and last data is there 55 milligram of sodium chloride is present per liter of water. Then how much temporary hardness is there? What is the value of temporary hardness and what is the value of permanent hardness? You want to know that water is if hard is how much you can say hardness is there, temporary hardness. What is the value of temporary hardness and what is the value of permanent hardness, and what is the value of total hardness? Then easily you can calculate, very easily, that here one factor is there. You have to multiply by one factor, multiplication factor for converting into equivalents of calcium carbonate. Then very simple factor is there. Suppose calcium bicarbonate is there, then calcium bicarbonate molecular mass is 162, Then in this calcium bicarbonate, 100 gram calcium is there. Okay, 100 gram calcium is there. Always 100 gram will be fixed, because you want to convert into tell in the term of calcium carbonate. Calcium carbonate. That's why now it's suppose in calcium bicarbonate is 162 molecular mass, and this molecular mass calcium bicarbonate contains 100 gram calcium carbonate. 162 contains 100. Then 1 gram, how much? 100 divided by 162. Then 100 divided by 162. This is actually factor. If we can say you are talking about calcium bicarbonate, if you are talking about magnesium bicarbonate, then now here molecular mass of magnesium bicarbonate you have to write it down. As for example, in case of magnesium bicarbonate, 146 is the molecular mass. Then 100 divided by 146, 100 will be common, because 100 is the molecular mass of calcium carbonate, CaCO3. Then 100 by 162 calcium bicarbonate. But in case of magnesium bicarbonate, 100 by 146. Like that way, other also, suppose magnesium sulfate, you want to tell. Magnesium sulfate is present in water. Then magnesium sulfate molecular weight is 120. Then 100 divided by 120. Like that way, if magnesium chloride is present, then for magnesium chloride molecular mass is 95. Then 100 divided by 95. Like that way, this is the you can say multiplication factor. Then this factor you have to use. Then here now what data they have given accordingly. Now calcium carbonate equivalent you want to calculate of first data is that 16.2 milligram of calcium bicarbonate is there. Then how much temporary hardness is there due to calcium carbonate? Then 100 divided by 162 into 16.2 into 16.2. After solving, you will get 10 milligram. 10 milligram, you can say hardness is there. 10 milligram. Like that way, magnesium bicarbonate is 29.2 milligram. Then magnesium bicarbonate. Then 100 divided by 146. 146 why? Because of magnesium bicarbonate. Molecular mass is 146. Then 100 divided by 146 into 29.2. Because in 146 100 is there. Then in 1 how much? Then in 29.2 how much? Simple. Just to multiply. The 100 divided by 146 into 29.2. Now after this solution it will give 20 milligram. Then hardness is 20 milligram. Okay. Then both are actually temporary hardness, because both are bicarbonate. Calcium bicarbonate, magnesium bicarbonate. Calcium bicarbonate is 10 milligram. Magnesium bicarbonate is 20 milligram. And this temporary hardness, how much total temporary hardness? Total temporary hardness. Then 10 plus 20, 30 milligram per liter. 30 milligram per liter. That is this is the temporary hardness. 30 milligram per liter. Okay. And now same way you can say if calcium chloride they have given 33 milligram calcium chloride is there. Then chloride and sulfate I told you that will create big problem, permanent hardness. Then calcium chloride 33.3 milligram is there. Then 100 divided by 111. Calcium chloride is molecular mass 111. Then 100 divided by 111 into 33.3. After solving it will come 30 milligram. 30 milligram hardness is there, permanent hardness. And This again, next data is in water 18 milligram magnesium sulfate is also there. Then this also 100 divided by 120. 120 is the molecular mass of magnesium sulfate. Then 100 divided by 120 into 18 milligram. It will come 15 milligram after solving 15 milligram. Then now this sulfate and chloride. Then this chloride and sulfate is responsible for permanent hardness. Calcium magnesiums are common in both temporary and permanent. These anions are can say differentiating. Differentiation is due to difference is due to this this carbonate, bicarbonate and chloride and sulfate. Then now this you have calculated permanent hardness. Then due to chloride it was 30 milligram and due to sulfate it is a 15 milligram. And then what will be the total permanent hardness? Then you add this means 30 milligram plus 15 milligram. Due to chloride 30 milligram and due to sulfate it is 15 milligram. Then total 45. Permanent hardness is 45 ppm and milligram. This you can tell 30 milligram per liter, or now it is become 45 milligram per liter. 30 plus 15, 45 milligram per liter, or also milligram you are talking, milligram per liter. Hence you can tell 45 ppm also. And temporary hardness was 30 milligram per liter. That also you can tell because it is milligram per liter. Hence you can tell 30 ppm, 30 parts per million. Then now temporary hardness also you are knowing and permanent hardness also you are knowing. Hence total hardness is 30 plus 45, 75 milligram per liter. Also you can tell 75 parts per million. And here you should know sodium salts do not cause hardness. Sodium salt does not, sodium or potassium does not count hardness. Okay, hardness is due to calcium and magnesium mainly. Okay, then now I have discussed about this hardness of water and how will you calculate also I have discussed. Now I am stopping. Okay, thank you.